Hello everyone. This week we're going to be talking about a very exciting topic. Fonts. It started so simply, doesn't it always? As a software developer, I work with text all day. When I was in college, I decided that I wanted to find the perfect programming font. I wanted the ability to easily differentiate uppercase O's from zeros, the ability to differentiate a lowercase l from a 1. Programmers tend to like working with monospace fonts because sometimes the positioning is important. A lot of monospace fonts are specifically designed for programming and meet those criteria. But I wanted more. It started with the letter A. I realized that I don't write my letter A like this. I write it like this. There were always one or two characters that weren't quite all that I had hoped for. G, J, Q. Eventually, I found a font that was pretty close, but not perfect. So I decided, okay, well, I'll get a font editor, and I'll edit the font that is closest to the one that I really want. And this opened up my eyes to a whole world that I had no idea existed. So to understand fonts, we're gonna have to go all the way back to the beginning. The printing press. Now, how do you make a copy of something that you've written? There's the naive way of just rewrite the whole thing, and that's what scribes did for centuries. You could do something like carve it into a piece of metal or wood to create an inverse and then use that as a stamp with ink. But then that's all that that piece can be used for. You will only be able to print that page with something you've carved. So that gets expensive, and if you make a mistake, well, you're stuck with it. So what you really want is the ability to print individual characters and rearrange them as needed. So you'll make a stamp with a single character on it. You'll place this in some kind of frame and throw some ink on the whole thing and stamp it down, and we'll call that movable type. And this is really the birth of the first fonts. Typewriters abstracted this concept even further. You didn't need to work out a whole page one at a time and stamp the whole thing. You could type one character at a time. Then, with the advent of computers, we had to start working with pixels. In the old days of computing, there was a binary state for a pixel on a screen. That is, it was either completely on or completely off. The other issue that was raised at this time is printing. At the end of the day, a printer has to know whether to make a dot or not. Similar to computer monitors, printers needed to know whether or not they were making a dot on the page. So this gave rise to what are called bitmap fonts. These were simple maps of which bits would be turned on for a particular character, hence the name bitmaps. But there was a problem. What if you wanted to change the size? Have you ever tried to zoom in really close on an image before? You'll notice that things start to look really muddled and jagged and ugh. You could store the glyphs at really high resolution and always scale them down. But this has three major problems. First of which is storage space. It takes a lot more space to store a high resolution bitmap. At the time, space was expensive. Number two, processing. It takes a good deal of processing to scale something well. And the third problem is maximum size. If you want to go larger than the native resolution of that font, you're right back where you started. To make a very long story short, we settled on something called vector images. Those of you who work with images a lot may be familiar with a format, very popular, called Scalable Vector Graphics, SVG. Basically, vector graphics are mathematical equations. They can describe something with near infinite precision. As the name would suggest, they scale very easily to just about any size. And since the equation is far smaller than the graphics would be for something at that scale, the process of graphing it out is actually more efficient, both space and processing-wise, than it would be to store them as images, which solves all three of our problems. So in effect, every time you type a character on your keyboard, on your phone, on your laptop, it has to draw that glyph. It's almost like the computer is using a pen. So in a way, we've kind of turned computers into our scribes, which is kind of remarkable when you think about it. We just take for granted that when I push the letter A, an A appears on the screen. In my selected font, color, blended nicely with the background, it looks great. You print it and it comes out looking the same. Obviously, there is a lot more to it than this. Kerning, strokes, accent characters, emoji, and not to mention optical character recognition, which is the inverse of this equation. Fortunately, I was able to see how deep this hole goes before I started going deeper into it myself. I eventually decided it was better to settle for a font that was 98% of what I wanted than to try to fix it. Fonts and our own ability to recognize the same characters in different styles are remarkable. It's far more complicated than most people ever think about. And that's it for this video. I hope you found that interesting. As always, I'll put links in the description so you can take your own deep dive and learn more about these subjects. I'll be back again next week with another video that I hope you'll find interesting. Until then, stay curious.